Hello students, I hope you are good, well and fine, and today we will be continuing our discussion on the topic of relations and functions of class 12th chapter 1. As we discussed, in theory class, what we discussed, we saw a relation definition. Yes, we saw the relation definition. Then we saw domain, range definition. What do we mean by domain? What do we mean by range of a relation, of a given relation? Okay. Then what we saw the representation, representation of what? Representation of relations, arrow diagram and set builder relations, set builder method. Okay, then we saw possible number of relations. Okay, then what we saw? The possible number of relations. Okay, and the finally equivalence class of an element A and equivalence classes. Okay, don't confuse with them. So we saw all of these. Now based on these, we will be seeing NCERT exercise 1.1. Let's solve with me. So first of all, first question of NCERT says, determine whether each of the following relations are reflexive, symmetric and transitive. Okay, let's solve together. So first, the relation in the set A, this means my R is a subset of A cross A, and A is my what set? 1, 2, 3 till 40. Okay, now what? R is defined as like this. The difference, the 3x minus y is equals to 0, or I can say 3x is equals to y. Okay, all the pairs are my relation, the pairs such that 3x is equals to y, where x and y belongs to A. Okay, I hope this is very clear to you. Okay, now what? So let first of all list out all the elements, because the elements are not that much, so we can easily list out and answer our question. So 3x must equals to y. So if x is 1, x1, y is 3, x2, y is 6, x3, y is 9, x4, y is what? Y is 12, and x5, y is 50. Is this belongs to the R? No. Why? Because R must be the subset of A cross A, and in A cross A we do not have any element 5, 15 because of this. Because this is the element, this 15 must belongs to in this set, and here we can easily see, what we can easily see is this, that 15 is not belonging to this set A or in this set. Okay, so this element is not going to in the relation R. Okay, so we restrict ourselves to these elements only. So here, if you see, is this reflexive? No. Why? Because take any element in from this set, the first set in the Cartesian product, take any element, say 1, then 1 comma 1 must also belongs to R. No, as you can see, 1 comma 1 not belongs to R, so it is not reflexive. So it is not reflexive. Now let's see for transitivity. Sorry, before that, let's see for symmetricity. Symmetric. So for symmetric, if A comma B belongs to R, then B comma A also belongs to R. Let's see. 1 comma 3 belongs to R. Yes, indeed. Does 3 comma 1 belongs to R? No. So this means it is not a symmetric also. So not symmetric. Okay, now let's see for transitivity. For transitivity, what you have, first of all, you have two conditions or two assumptions to be satisfied. What are those two conditions? A belongs to R, A comma B, B comma C belongs to R, then A comma C must also belongs to R if it is a transitive. Okay, so 1 comma 3 belongs to R. Yes, 1 comma 3 belongs to R. 3 comma 9 belongs to R. 3 comma 9 belongs to R. Does 1 comma 9 belongs to R? Does 1 comma 9 belongs to R? No. As you can see, no pair of 1 comma 9 is there in R. So from this I can easily say that it is also not transitive. So my first part is neither reflexive nor symmetric nor transitive. I hope this is very clear to you. Okay. Now what about the second one? Let's see the second one. Here my relation R is in the set of natural numbers. So R is my subset of n cross n. Okay. This n is natural numbers set. So R is defined like R is collection of all ordered pair such that the y is equals to x plus 5. Yes, and x is less than 4. So this means the only possibilities x less than 4 and x also from natural number. This means x is 1, 2, 3 only. So this means if x is 1, then y is 6. If x is 2, then y is 7. If x is 3, then y, from this I can say y is 8. Okay, so from this I can easily say that 1 comma 6 is my one pair, 2 comma 7 is my another, and 3 comma 8 is my another pair. So the only possibilities are these pairs. Okay, so as n, the natural set is like this, 2, 3 till plus infinity integer. So I'm just writing dash dash dash. Okay. Now what? Now if it is reflexive, for reflexive, take this set, the first set, take any element from this set. I'm taking this element. Then is 2 comma 2 belongs to this set? No. As you can see, 2 comma 2 doesn't belongs to R. This means it is not reflexive. So reflexive? No, it is not reflexive. Now let's try to see, is it symmetric? So for symmetricity, A comma B belongs to R, okay, then B comma A also belongs to R, okay. So if you see this pair 1 comma 6, 1 comma 6 belongs to R, is 6 comma 1 belongs to R? No, it is not. So as you can see, 6 comma 1 doesn't belongs to R, so this means that it is also not symmetric. So it is also not symmetric relation, okay. Let's see about the the transitivity. What about the transitivity? So first of all, for transitivity, A B belongs to R, B C also belongs to R, and then only we can talk about AC belongs to R. If this is happening, then my relation is transitive. If it is not happening, then it is not transitive. Simple as that. So as you can see, 1 comma 6 belongs to R, 6 comma, there's no element which is starting from 6, okay, don't worry. What about 2 comma 7 belongs to R? Yes. So 7 comma, so there's no element which is starting from 7. As for transitivity, we need the condition that this going to happen, okay. So it is not the condition over here. Same with this element. So 3 comma 8 indeed belongs to R, but 8 comma, we don't have any element, any pair in R which is starting from this 8, okay. So what we can say about its transitivity, okay. So we have this information, we do not have this information, okay. But as you see, what if let's say if it is not transitive, this means that we have, if it is not transitive, this means we have A comma C doesn't belongs to R. Yes, indeed. If it is not transitive, then if it is not transitive, if it is not transitive, this means A comma B belongs to R. Yes. B comma C also belongs to R. Yes. But A comma C does not belongs to R. Is there any such pair that this happens but this doesn't happen? Is there any pair? Is there any pair such that this happens, but this also happens? No, we do not have such thing. Okay. So we can say that, okay, we do not have this as our condition satisfy. Okay. Okay. Now, if you talk about if you talk about this for transitivity, this happens, okay, this happens and this happens, okay. We have this as our information. We do not given that this is a pair as our information, okay. And we need to show that A comma C belongs to R, okay. Then what in such cases when you have one condition satisfy, another about another not given, so we in such cases we always say that it is true or it is transitive. So it is transitive. So all please be keep this point in mind that it is transitive. Why? Whenever you see such conditions that A comma B belongs to R and we do not have such pairs that starts with this element, okay, then we always take that it is transitive, okay. I hope this is clear. So it is transitive. Okay, now let's see the third part. So my A is 1, 2, 3, 4, 5, 6. Okay, so A is 1, 2, 3, 4, 5, 6. Okay, now what? Now R is a relation from A to A. Okay, so it must be the subset of A cross A. R is defined like what? Pair of x, y such that y is divisible by x. So x, y such that y is divisible by x. Y is divisible by x, or in other words I can write it as like x divides y. Yes, x divide y. So x divides y. This means what? This means is x and y both belongs to A. So x divides y. So let's just list all the elements. X divides y. So 1 divides 2. Yes. 1 divides 3. Yes. 1 divides 4. 1 divides 5. 1 divides 6. And one element I forgot is 1 divides itself also. Yes. 1 divides 1. Okay. Now 2 divides itself. 2 divides 3. No. 2 divides 4. Yes. 2 divides 5. No. 2 divides 6. Yes. 3 divides 3. 3 divides 6. Yes. No other elements. Okay. 4 divides 4. Yes. 5 divides 5. Yes. And 6 divides 6. Yes. So all the possible elements will be these 4, 5, 5, 6, 6. Okay. Is it reflexive? For reflexivity, take this set, take any element. Suppose this is 2, 2 belongs to this. Yes, 2, 2 belongs to this. Yes, if this happens, then check for all the elements. So is 3, 3, 4, 4, 5, 5, 6, 6 and 1, 1 all R belongs to itself? Yes, you can see 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So as from definition, we can say it is reflexive. So it is reflexive. So as you recall, reflexivity is A, A belongs to R for every A belongs to the set A, where R is my relation from A cross B from this set. We are talking about for every A here. So every A in here. So take any element, the pair of itself must be there. So like 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. I hope this is very clear to you. Now let's talk about what symmetricity says. Now symmetric relations are if A, B, if A, B belongs to R, then B, A also belongs to R. So whenever this happens, first of all, whenever this happens, then this also happens. Then only we can say that my relation is what? My relation is symmetric. Okay, so let's see. So 1, 2 belongs to R. 1, 2 belongs to R. Does 2, 1 belongs to R? Try to see. Is there any element over here 2, 1? No. So 2, 1 doesn't belongs to R. So this means this property is not satisfying. Then I can easily say what? That it is not symmetric. Okay, let's talk about transitivity. Okay, let's talk about it. So for transitivity, what we need, A, B belongs to R, B, C belongs to R. Then A, C must also belongs to R. So this means what this means is quite simple and straightforward. Whenever this 2 happens, if this going to happens, then I can say that it is transitive for every what? For every A, B and C. Okay, so okay, now let's check. So if you take, let's say 1 comma 2 and not 1 comma 2, let's take 2 comma say 2 comma let's take 2 comma 4 and 4 comma, where is 4 comma, say 4 comma 4. Okay, 4 comma 4, 2 comma 4 and 4 comma 4. So this means 2 comma 4, 2 comma 4 belongs to R. Yes, it is satisfied. Okay, it's look like it is going to satisfy. Okay, let's try to see from these listed elements. Let's try to see from this. So if xy belongs to R and yz belongs to R, then to show xz belongs to R. If this happens, then I can say that my relation is transitive. Okay, so if this happens, this means x divide y, this means x divide y, this means y is multiple of x. Okay, y is multiple of x. From this, y divide z, this means z is multiple of y. So z, say x is k1, y is equals to x k1, z is equals to y k2. Okay, now from this, as I know the value of y I can take is like this, so put the value over here. So z is equals to x k1 k2. Here k1 and k2 are my integers. Sorry. Okay, so k1 and k2 are my integers. Sorry for the disturbance. So where was I? So y was x k1 and z was y k2, where k1 and k2 were from some integer. Okay, k1 and k2 some integers. Okay, put y value over here, then my z will be x k1 k2. The product of two integers will also be integer. So x1 x2 is my product, is also some integer. Okay, from this I can say that z upon x is equals to some integer. Yes, some integer. So this means that x divides z. So x divides z. This means z is divisible by x. So z is divisible by x. This means x comma z belongs to R. Yes. So z divisible by x. This means x comma z belongs to R. So from this I can say that it is transitive. I hope that it is clear to you. Here neither, here only transitivity was there. Here the reflexivity and the transitivity was only there. Okay, I hope this is clear. So neither reflexive nor symmetric nor transitive, neither reflexive nor symmetric but transitive. Please keep the thing in mind that whenever you have AB belongs to R, BC belongs to R, then AC also belongs to R. Whenever you have this condition as satisfying but do not have any pair like these, okay, then in these cases we always take that my relation is my transitive. Okay, because it doesn't violate any part of this definition. What we want is to think that my definition is not get violated or not get any contradiction. So no contradiction over here, because we do not have any element or any pair which starts with the same element over here in this pair. Okay, so we say always we take that it as transitivity. Okay, so here the reflexive was there, the transitivity was there, but not symmetricity. Okay, I hope you understood every bit reason of these questions we just saw, and you recalled every definition of reflexive, symmetric, and transitivity. So that's it for today. Thank you having with me.